We're going to come back to here. Today is the 15th. We're missing all our pretty voices, but that's okay. We can keep going. There are 3 ways that natural selection can change a population. Stabilizing selection is when average is awesome. So this average baby has a better chance of surviving birth, has a better chance of surviving infancy. Average is strongly favored in human birth weight. So that's stabilizing selection. We get more and more average and fewer outliers. What does it mean if you disrupt things? And this is notes, so you should have your partial notes up and be filling these in. We're going to do just a couple slides, then finish that podcast. Gesundheit. What does it mean if we disrupt something? Shake it up? You don't know? Okay, it sounded like you were starting to say that. Shake it up! Change things! Disrupt the status quo! So in disruptive selection, both extremes are favored. Being average will get you killed, and both extremes are favored. So what we see after selection, if we have disruptive selection, is either that bell gets shorter and the whole thing gets fatter, or sometimes we actually start to develop 2 humps. Remember what kind of distribution that's called? Bimodal. Sometimes we actually get a bimodal, oh hey, it's on there. Sometimes we actually get a bimodal distribution out of that. But the average is not good in the case of disruptive selection. So where could we see something like that? I'm glad you asked. I would like you to look at this adorable little creature. How's that? It's not a walrus, actually, but it's a pinniped, so you're close. Pinnipeds are marine mammals whose, what would be hands and feet on most mammals are kind of fused into flippery things. So walruses are one pinniped. Sea lions are a pinniped, but this is not a walrus or a sea lion. What's left?
Seal.
Seal. This is a harbor seal. And they're a really widely distributed species. They like cold water. They're a cold water marine species. They're adorable. They're cute. You find them along the Arctic coasts, sort of the northern coasts of the continents. Find them off the European coast, Canadian coast, North Atlantic waters. They're so cute. So cute. So cute. And so tasty to things like orcas. I've never eaten one. But orcas, what we used to call killer whales, and sharks, love them some seal snacks. Nom. So if you're a seal, well, okay, here's one of the interesting things about humans at this point in history. I think I've asked you this before. I'll probably ask you this again before it's all over. How many of you were chased by a predator species larger than you on your way to school here? Saber-toothed tiger, dire wolf, something with the intent that it was going to eat you? Really? We'll talk more later. I want video evidence. We live at this interesting point in history and time and space where there's nothing trying to creep up and eat us in the night. Sorry to creep you out there. We don't typically have mountain lions dragging our children from the yard. It happens in some parts of the country. It does, but it's not common. We're not being pursued by wolves on our way to get water from the well. Life is pretty easy, honestly. Huh? Spiders. However, there is not a spider around here big enough to wrap you up and suck you dry.
Around here, they're still around here?
Well, but they're not, but yet they're not predators. No, not that I know of.
One in the world.
Not that I know of. So, if you are being chased by a predator, what are your options for surviving here?
Duck and cover.
Okay, if you don't escape, you die. Fight back. Basically, it's fight back or get the heck out, right? Fight or flight. Fight or flight, yes. So, what gives you your best chance to get away from them? Speed. Be fast. Be wily. Be maneuverable. Oh, now I'm dizzy.
When you've had too much coffee.
I'm going to sit down.
There's a big spider right here.
Hi, Gavin.
1 foot.
How are you? Being maneuverable would be great if you had to escape a shark and you were a harbor seal. Being little and wiry and fast and zippy. I'm not going to try zipping again. Ooh, that was bad. That would help you get away. If you can't be little and fast and zippy, what's the other option?
Camouflage.
Well, you can be camouflaged, and they all are camouflaged to a degree. But on the other end of flight, we said was fight or fear. What if you're so big and scary looking that all but the biggest sharks take a look at you and go, nah, not going to pick that fight. Who was it I was talking to who said, yeah, in middle school I used to get bullied, and then I got to high school and I shot up to 6'4", and I weighed 250, and suddenly nobody picked on me anymore. Said I wasn't mean. I've never been in a fight, but boy, I just look big and scary enough. They just don't bug me anymore. So if you're a harbor seal and you can't be little and zippy and wiry and fast, what if you're big and scary looking? Yeah, big boy. So what's interesting about harbor seals, one of the interesting things about them, now I think that's actually a mother and pup possibly. They have one of the biggest ranges for adult size among mammal species we know. Like if you look at the stats for coyotes, male coyotes, they'll say can go 55 to 65 pounds. That's the usual range. You don't find a whole lot over 65. You don't find a whole lot under 55. Adult bears, male black bears, they'll say, I think 725 to 800 pounds. It's a pretty small range considering the scale there. Adult male harbor seals can go anywhere from 120 pounds to 300 pounds. That's a crazy range.
That's a lot.
So, the biggest adult male harbor seals are more than twice the weight of the smallest. But guess what? There aren't a whole lot in the middle. They all tend to be either little, fast, wiry harbor seals who can get away from sharks, or they tend to be what I'll call big guys who aren't very fast. They're too big to be real fast. But they're big enough to bluff a predator. They're big enough to kind of go, really? Really? You want to pick a fight with me? And the predator goes, maybe not so much. It's cool. It's okay. There's not a whole lot in the middle. So if you're a middle-sized harbor seal, you're not as fast as the little ones. You know the joke about two guys out hunting and suddenly they're being chased by a grizzly bear, right? And the one guy says to the other, oh my God, I can't run faster than a bear. I'm going to die. And the first guy says, I don't have to run faster than a bear. I just have to run faster than you. That middle-sized harbor seal can't outrun the littlest harbor seal. So who gets away when the shark or the orca or whatever predator it is chasing them? When the smaller one gets away, the middle-sized one is lunch. And with those big ones, if they're going to try to compete with those big ones, they're not as tough and scary. They're not as able to put on a good fight or put on a good bluff. So if there's if you're a predator and you're looking at a middle-sized harbor seal and a big guy, who are you going to eat? I'm not fighting the big guy. But you look tasty, sir. So we tend to see this pattern of disruptive selection where we end up with both extremes, but being average really isn't very good. So in directional selection, one extreme is favored. Having one extreme version of a trait is a good thing. Having the other tends to get you killed. So, yay for having the biggest head circumference. but maybe having the smallest head circumference gets you killed. So you end up with a normal distribution after a while, but it shifts, either upward or downward. And this can operate in either direction, I should say. So this is where, over time, the traits in the population shift towards one extreme. So that bell, that hump of the curve, moves in just one direction. And this doesn't cause bimodal distributions. It doesn't cause short, fat bells. It causes a normal distribution, but average moves. The mode moves. And the best known example of this is these guys. You know what that is?
It's a moth.
It's a moth. It's a pretty little moth. It's called a peppered moth. And it's fairly well camouflaged on that light bark, isn't it? It blends it. From a distance, it'd be actually kind of hard to see. So these existed all over England prior to the Industrial Revolution. Do you guys do Industrial Revolution in the U.S.? What happens in the Industrial Revolution? Factories. We start burning a lot of coal. That pretty white tree bark that you see there, do you know what happens in cities with factories? Oh, it turns black. A lot of people I know who lived in Youngstown, Ohio, or Wheeling or Pittsburgh in the 1950s talk about how you didn't hang wash out to dry because it would be covered with black soot when you took it in. So hence you would have a clothesline in the basement of the house. Yeah. So you cover those trees with black soot, and here's the funny thing. The funny thing is that really well camouflaged moth suddenly isn't so camouflaged anymore. Nope, it sticks out like a sore thumb. And as a matter of fact, can you see the dark moth in the picture? Just barely. It's right there. It's really hard to see. So prior to industrialization, when you had the, whoops, well, that wasn't what I meant to do. When you had those very light-colored moths, they were pretty well camouflaged. Birds didn't eat them. Great. After you cover the barks of the trees with coal soot, suddenly they stick out like a sore thumb. And there's variation in the population. You have a range of moth colors. You have everything from really, really light ones to ones that are more an even mix, to some that are really pretty dark, that have almost no speckling. Well, after industrialization, when they started looking at populations of peppered moths around British cities, guess which way the population had shifted? Towards the darker moths. The white moths were being picked off. And so pretty soon the entire population had shifted. You still had a distribution, you still had variation, but you had very few of those light-colored moths. And if you looked at the distribution with color being the characteristic, that had shifted considerably. And so you had much, much darker moths on average. That's directional selection. To finish the podcast, we said that in order for natural selection to be occurring at all, what were the criteria that had to be met? Has to be variation. Well, some kind of variation. We don't know if it's from a mutation or what. There has to be variation.
Large population.
Well, here we're thinking about the things that shake up equilibrium. That's what you're thinking about. We said that for evolution to be happening, life has to be hard. There has to be variation. So we last left our innocent little birdies on the Galapagos with worms crawling up their noses and eating their brains. Ew. Let's go back to that and see what happens. If we think, knowing that these were in fact two different species, so we had the small and we had the medium, but they were actually capable of interbreeding this whole time, so we could kind of look at them as one continuous species. What kind of selection did they experience? Was any of this good? No. Was any of this good? No. Where do they end up after selection? They end up doing well there. Which kind is that? It's actually stabilizing. Both, it's a complicated one because it's bimodal, but you're favoring something that's this intermediate, this middle ground. Middle ground is doing better than small or medium. Okay. So a word about why we skipped Friday work. The Friday work is a way to try to expand on stuff for some folks and give a little bit more support to other folks and get other people thinking about scientific method. That's the thing that, unfortunately, as we walk through the winter where we have lots of schedule delays, if we're going to skip something, it will be that on a Friday. So if we have a snow day